Huh?
It's 2 in the afternoon. You just finished a big lunch. Your eyelids feel like they weigh 10 pounds each. Your brain feels like it's wading through fog. You tell yourself it's just the food. But the real answer is far stranger. What's happening inside you right now was built over millions of years, long before lunch breaks, long before chairs, long before there was even a word for meeting. Start with what your body is actually doing. The moment food hits your stomach, a massive redirection begins. Blood starts flowing away from your brain and toward your gut. Your intestines need fuel to break down what you just ate, and your body treats that job as urgent. More urgent, in fact, than keeping your mind sharp. Why would evolution build a system that trades your focus for your digestion? The answer starts with a nerve you've probably never thought about. It's called the vagus nerve, and it runs from your brainstem all the way down to your gut. The moment your stomach stretches with food, the vagus nerve fires a signal upward. That signal doesn't just say digest, it says power down. Neuroscientist Clifford Saper at Harvard Medical School has spent decades mapping the brain's sleep switch, the cluster of neurons that flips your brain between alert and drowsy. His research shows this switch isn't only controlled by darkness or exhaustion, it's controlled by internal signals too. Signals like the ones your gut sends after a meal. Here's where it gets stranger. Deep in your hypothalamus, there's a small group of cells called orexin neurons. Orexin is a chemical that keeps you awake, alert, and hunting for food. When you're hungry, these neurons fire like crazy. They keep you scanning, moving, searching. But the instant your blood sugar rises after eating, something flips. Neuroscientist Denis Burdikoff, who has studied orexin neurons extensively, found that these same cells are exquisitely sensitive to glucose. Once glucose floods your bloodstream, orexin activity drops sharply. The chemical that was pushing you to find food suddenly goes quiet. Your body doesn't need you hunting anymore. It got what it needed. So why keep the engine of alertness running? This isn't just a human quirk either. Even fruit flies do it. Researcher William Jai at Scripps Research studied what happens to flies after they eat and found a strikingly familiar pattern. Flies that eat larger meals sleep longer afterward, and the effect scales directly with how much sugar and protein they consumed. A fly has never sat through an afternoon meeting. A fly has never felt guilty for yawning at its desk. Yet the same food-triggered sleepiness shows up in its tiny brain. That's not a coincidence. That's a signal that this mechanism is ancient, wired in far below the level of human culture or habit. So picture it, not a lunchroom, not a desk, a clearing somewhere in Africa hundreds of thousands of years ago. Your ancestor has just eaten. Maybe it was a kill shared among the group. Maybe it was fruit gathered after a long search. Either way, something important happens next inside their body. Digesting food, especially a large or fat-rich meal, takes enormous energy. Blood rushes to the gut. Resources shift away from muscles, away from sharp vision, away from quick reflexes. For a predator watching from the tall grass, this would be the perfect moment to strike. A slower, foggier human should be more vulnerable, not less. So why would evolution allow this state to exist at all? Wouldn't a hungry ancestor who stayed alert after eating have a survival edge? The answer flips the question upside down. After eating, your ancestor wasn't in a position of weakness. They were, briefly, in a position of safety. Think about when humans typically ate large meals in the deep past. Not constantly, not on a schedule. Meals came after successful hunts, after long gathering trips, often shared back at a camp or shelter, surrounded by others. Group settings meant more eyes watching for danger. A full stomach usually meant the hardest, riskiest work of the day. The hunting, the foraging, the traveling was already finished. There was no calorie-burning payoff left to chase. Resting after digestion wasn't a liability. It was the reward for a job already done, and it happened in the safest window of the day. There's a deeper efficiency here too. Muscles and brains are expensive. They burn enormous amounts of energy just to stay ready for action. Digesting a meal is also expensive, arguably one of the most energy-hungry processes your body performs. Running both systems at full power at the same time would be wasteful. Your ancestors' bodies evolved a kind of internal budgeting. When food arrives, temporarily lower the cost of alertness and pour resources into extracting every calorie from what was just eaten. It's not laziness. It's an ancient accounting system, prioritizing the biggest metabolic project of the moment. Insulin plays a supporting role in this story too. When you eat carbohydrates, your pancreas releases insulin to move sugar out of your blood and into your cells. Insulin also affects an amino acid called tryptophan, making it easier for tryptophan to cross into your brain. Once inside, tryptophan gets converted into serotonin, and serotonin can be converted into melatonin, your body's sleep signal. This is part of why a carbohydrate-heavy meal, more than a light salad, tends to leave you reaching for a nap. Your ancestors weren't eating processed pasta or white bread, but the same biochemical pathway existed whenever they ate ripe fruit, honey, or starchy roots. High-energy food has always come with this built-in drowsiness switch attached. Here's the counterintuitive twist most people never consider. This sleepy state isn't a malfunction your body tolerates. It's a state your body actively builds, on purpose, every single time. Salk Institute researcher Sachin Panda, who studies the biology of circadian rhythms and feeding, has shown that your body doesn't just react passively to food. It runs on internal clocks that anticipate meals, prepare for them, and shape your energy levels around them throughout the day. The dip you feel after lunch isn't only about what you ate an hour ago. It's also shaped by a rhythm your body expects, tied to daylight, tied to your internal clock, tied to patterns your ancestors lived by for hundreds of thousands of years before electric light ever existed. Now bring this back to your afternoon. You sit in a meeting after lunch, struggling to keep your eyes open, and you feel like something is wrong with you. Nothing is wrong with you. Your vagus nerve is doing exactly what it evolved to do. Your orexin neurons are doing exactly what they evolved to do. Your body doesn't know the difference between a conference room and a savanna clearing. It only knows one thing. Food arrived. The gut needs power. It's safe enough, for now, to power down the rest. Modern life just removed the safety net that used to make this state harmless. Your ancestors could rest after eating because there was no clock demanding their attention 30 minutes later. There was no deadline, no inbox, no meeting agenda. The post-meal lull used to fold naturally into rest, sometimes even short sleep without consequence. Today, you're expected to fight through it, sitting upright under fluorescent lights, forcing a system built for stillness to perform sharp, focused work. The fogginess you feel isn't your brain failing you. It's your brain following instructions written long before deadlines existed. Even the foods that make this worse are telling on you. Heavy, fat, and carb-rich meals trigger a stronger version of this response than small, lighter ones. Your body reads a large meal as a major event, worth a major shutdown. It's the same reason a small handful of nuts barely touches your energy, while a large plate of pasta can make your eyelids feel bolted shut. Your gut isn't being dramatic. It's calibrating its response to the size of the job in front of it, just like it always has. So the next time the afternoon slump hits, notice what's actually happening beneath the surface. Blood is shifting toward your intestines. Orexin neurons are quieting down. Serotonin is rising. A rhythm older than language is nudging your body toward rest, exactly the way it nudged a well-fed ancestor to sit back after a hard day of hunting or gathering. Your ancestors weren't lazy for feeling this way, and neither are you. It's 2 in the afternoon. Your eyelids still feel heavy, your focus still drifts, but you understand it now. This isn't a modern flaw, it's an ancient reward, misplaced in a world that never learned how to pause.